Good evening. I hope all of you are ready to complete the second part of linear programming problem with me, so that if you have not done this part properly, this part means what? Solution of linear programming problem. Formation of linear programming problem I have explained. If you are good in English, in understanding the statement, you can form a linear programming problem. Today's class I will be showing you how linear programming problem can be solved efficiently by two methods. One is the corner point method and the other one is Isoprofit or Isocost method. So without wasting our time, let us start. What is corner point method and what is Isoprofit or Isocost method? The method I will explain here, it is explained in all the books. Easily you can go through, but it is better the concept you practice with me now. Get ready with your graph paper, plot the document, plot the problems of linear programming problem, say number 1, 2, 3 this way, and then solve it. So first problem I have chosen a maximization problem. I will show you by both the method how to solve this problem. For number 1, it is maximized. You can see the problem I have shared with you here. Z is equal to 3x plus 2y subject to the constants. What I have told you in the last class, you have to plot the constants properly. So, if you are going to answer this way in your board paper, obviously it's a descriptive question. You will answer this manner. Just no need to copy the problem. You will start this manner directly, treating given inequations as equations only. What will you get? Minus 2x plus y equal to 1, x is equal to 2, x plus y equal to 3, and xy equal to 0. We have to plot this. For that, we need to draw a coordinate axis and then we will decide the region. So let us take this one as y-axis and this thing as x-axis. As I told you in the last class, you express the line in intercept form. You write x by minus half, y by 1 equal to 1. First you write this intercept form, minus half minus 0.5. Suppose you have taken these 2 units as or 4 units as 1, because this measurement 1 is very small. So I like to take this was 1, yeah, or you can take 1 unit this way as you like. I am taking these 4 squares as 1 unit. So 0.5 will be here, okay, and this method is important. Whenever smaller coordinates are given, you can assume this way, you can proceed this manner. So what I have taken, that will write clearly that 4 squares, small squares, the smallest squares is equal to 1 unit. And this is very helpful when you get fraction. Okay? So this point is going to be half of 1 unit, that is minus half 0, and 1 unit over there, 1, 2, 3, 4. These 4 squares will give you 1 unit. So in our calculation, this is 0, 1. So now draw the line. If you draw the line, it's going to be like this. This is the line. This line is minus 2x, make it a bit thicker. Okay, this is the line. This point we have taken A, this one B, and A is minus of 0, B is 0, 1. But we need to plot the inequation. This will divide the two-dimensional plane in two halves. This I hope you all remember. What way it will divide in two halves? That either towards origin, origin means 0, 0, or away from it. So if you put x0, y0, the region will be directed that manner. So this is the region for first one. It's better if you take this line also same manner. For one line, one region. I am changing the color of my pen for this. This is AB line like this. And next one, x less than or equal to 2. 2 means how much? 2 means you have to count for 1 unit 4 squares. For 2 units 8 squares will be there. So here, just a minute. So this is x, y, and 1, 2, 3, 4, 5, 6, 7, 8. 8 is over there. Okay? So little bit you have to increase. This point is 8, 0. And then 8, 0, no. This is actually in terms of the graph, this is 2. Isn't it? So this is going to be 2, 0. And next line, if you take in intercept form, that is x by 3 plus y by 3 equal to 1. Okay? So let us take x by 3 and y by 3 1. It means we have to take 12 units here, because 1 unit is 4 small squares. So 1, 2, 3, 4. This point going to be 3, 0. Okay. What I have taken? 4 squares equal to 1 unit. Similarly, along y-axis you have to take 3 units along y-axis. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 0, 3. Clear? Achha. One thing, that x was less than or equal to 2. Less than or equal to 2 means what way it will be there? Let me take this thing over there. This is x equal to 2. Region due to this will be directed towards the origin, isn't it? Starting from the line, it will be directed towards the origin. Clear? Towards. It will be towards the origin. Okay? And the next one, when you plot x by 3, y by 3 equal to, name this line. This is x equal to 2. and this one you just increase it this manner. Okay? And join these two also. That this point you have taken AB, this one C, this one D, and this one E. Just join these two. But I should not take the same color of ink. I must change for it. So take this one black. So what will be the direction? I mean, not direction. I want to say what will be the region. The original question was all less than equal to. Have you seen that? All less than equal to. Now this line is x plus y equal to 3. If you take x0, y0 here, 0 plus 0 is less than 3. So region will be directed towards the origin. Clear? Hope you are understanding. So common region, you all can see that common region is intersection of these three colors. This one, and this one. So common region I am using another, different ink over there. This is going to be our common region, this thing. Okay? What we have to do there, if I go by corner point method, then if we go by corner point method, we have to find the corners first. Corners means point of intersection. Intersection of this line with x-axis, this one with y-axis, these two lines can be found easily. This one is what? Take this one as D. No, F. This point's coordinate x2, put it here, it is 2, 1. You can see it here also, 1, 2, 3, 4, 4 units. 4 squares is equal to 1 unit. Isn't it? And point of intersection of this one. This line and this line. This is going to be what? You can get it by solving, or don't solve it here, because here I have taken the coordinate axis, so count it. 1, 2, 3, 4, 1 is there, isn't it? This part is 1, and this is 1, 2, 3, 4, 5, 6, 7, 8. This point is going to be 1, 2. Is that clear? So the feasible region is, you name this O, C, F, this you write G. So feasible region is O, C, F, G, B, and then O. Understood? What we have to do there, this objective function j is equal to 3x plus 2y. The question was maximize j is equal to 3x plus 2y. This we are going to maximize. Maximize j is equal to, it was maximize j is equal to, so in corner point method, I will be putting the values of x and y in it at these corner points. How many corner points? 1, 2, 3, 4, and 5. G that O, 0. Obviously not maximum over there. G that C is 6. G that if x2, y1, 6 plus 2, that is 8. G that G, 3 into 1, 2 into 2, that is 7. G that B, This is 0 plus 2, it is 2. Okay? So, maximum value occurs here, 8. So, Z is maximum when x equal to 2, y equal to 1 and Z max equal to 8. Clear? Now suppose you want to solve this problem by isoprofit method. I am telling you both the methods side by side. I need the same graph here. Okay? Or just let me draw it very first, or I can take a snapshot of it. Just a minute, I'll take. I'm just taking it here. Oh my God, it has not come fully. Sorry. It has not come properly. So, either you draw it again or you have to understand there only. Because this is the first problem. I am going to plot the graph again. But I will do very first, I promise, to explain isoprofit and isocost method. The rough sketch, because points are known now. So, we can go a bit faster. This way, then one line going like this, one line coming like this, other one is like this. Yeah. These points we got, we'll use it. Isn't it? This point we got 2, 1 and this is 1, 2. This one 0, 1. This is 0, 0. And the feasible region we have traced this way. There, in the same diagram. 2, 0, points also remaining the same. O, C, F, G, B. Before you do all those things, that definition, all those, you just try to understand what is our aim here. Our aim is to get maximum value of this function in the feasible region. Corner point method states that maximum value will occur in any one of the corner point. Okay, and that we have found. Isoprofit or isocost method, it will say that you put a minimum value to this, 3x plus 2y equal to 1, any value, minimum value you put. Okay. So, if we put the minimum most value, let us start with this, z is equal to, I am going to discuss isoprofit method or cost method. This time maximization problem, so we want to maximize. Now let 3x plus 2y equal to 1. When you plot this, what we are doing there? Putting a very small value of z. Because feasible region is away from it, I mean origin and those points, so maximum value, a previous idea that it will occur at maximum at points where x and y has maximum value. That's why we are putting this small value. Next part, what we have to do there, you plot the graph 3x plus 2y equal to 1. By intercept form, it will be x by 1/3 No need to be accurate, just to understand the method. So what we'll do there? I am taking this line here. This is say 1/3 and this is half. So this point is LM, L and M. So this isoprofit line, by putting x equal to 1, will plot first. I have given the rough sketch. Just little bit it will shift here. It's like this. Okay? So this is what line? That what you are supposed to maximize by giving a smallest value in it. Now what to do? This line, sorry, this line I need to move, in a direction parallel to it. So what have I told? This line I need to move parallel to it. Okay? So if I move it parallel, then what is happening? It's going like this, intersecting all the points of the feasible region. At which point at last it will intersect? The point which is furthest away from the origin. Okay? So where it intersects at last for maximization, it is away from origin. This distance of the line is maximum here where it intersects the point 2, 1. By isoprofit method, this is the point, it is 3x plus 2y equal to 8 we got, no? It intersects here. So at 2, 1 will be getting the maximum value. For maximization problem, it will be furthest away from origin. For minimization problem, it is very close to origin. So you have to take a bigger value over there and then move it towards the origin. Isn't it? Understood isoprofit line? I'll explain again in another sum. Then you will try on your own. Go for the next problem of the problem set I have shared with you. Just go through sum number 2. Solve this linear programming problem. Hope all of you can see that. Let us solve this by Isocost method. I mentioned this on YouTube by Isocost method. Okay? How to? So again, you will start the same manner, treating given inequations as equations only. So we treat given inequations as equations only. It means that minima you write here, minima z equal to 4x minus 2y. Then we have to plot x plus y 14, 2x plus y 24. No need to copy the whole sum, just start from here. And xy method 0. So now let us plot the first line. It is x by 14, y by 14, 1. Writing all in intercept form. Second line, x by 12, y by 24 equal to 1. Third one, 14 by 3, y by 7 equal to 1. How to plot? See, factor 1/3 has occurred over there. You must be careful about it. Normally, in board exam, they don't ask this question, 14/3. But if it comes, then what to do? If it comes, then what to do? Then graph paper will be accordingly. Got it? Or that millimeter graph, you can use this kind of graph will help me now to get it quickly. I'll assume that 3 small squares is equal to 1 unit. Then there will be no flaw, I am telling you. Got it? The very important concept here. If fraction arise, hope it will not come in board paper, but if it comes, then there will be problem. But there is another problem then. To mark it out will be very difficult. 1 square, 3 squares is equal to 1 unit. But if it comes, you have to do. This is a very interesting method. Only I am just little bit worried whether I will get 24 into 3 72 or not. Okay, let me try. Let me plot. I am starting from this corner. Which corner? I have written whole sum here. Huh? So let me move a bit over there. This is our y-axis. We can plot the line without much effort. Intersect form, if it doesn't work, then we can plot directly by putting values. Okay? So should I do that only? Directly by putting values, better we do. So first one is 14 0 0 14. 10 here. Okay? So 1, 2, 3, 4. This is 14. 14 0. Similarly, here. It's a practical problem. So this time I am changing my mind. I am going by intercept from this one just by putting values. Okay? So let us draw this line. This is the line. Which line is this? The first one. That is x plus y equal to 14. Next one 12 and 24. This is 0, 24. This is our AB, and this line is going to be, let me plot it with different color. This is for second line, 0, 24. Okay? So the line will pass through this point and this point. Now, before we plot those lines, we have to keep in our mind that all those inequalities are I mean less than equal to, only last one greater than equal to. Okay? So 14, 24 both are less than equal to. So this and I mean x0, y0 will satisfy both the lines. So this one will be towards the origin, and for the other line also towards the origin. Less than equal to, so it will start from the line. This I mentioned earlier. Okay, done, two lines. First one AB, second one is CD. And the last one, 14 by 3. 7. I am doing it approximately now, but what you will do there, you will take the points and then plot. Okay? Like 2y equal to 14 minus 3x, xy, so x0, y7, x2, y4. 2 points enough, or one more. Take one more. X minus 2 and y10. So that will be 0, 7. The points will be 0, 7, 2, 4. You take 0, 7. 1, 2, 3, 4, 5, 6, 7. 0, 7 is here. This is F. And next one is 2, 4. 2 points we got on the line. So you can plot it. Just take different ink. We are taking this one just for joining these two points. This is greater than or equal to 0, and region will be 0, 0 will not satisfy this, no? The line is greater than or equal to. You have the worksheet, you check. 0, 0 will not satisfy. So region will be directed away from origin. Okay, away. And additional condition is x, y greater than or equal to 0. It means the solution will be in first quadrant. This is 0, 0, 14, 0, 0b, and f. F how much? I wrote there 0, 7. You have to write this point also. That you can write easily. That is 14 by 3, 0. So understood. If fraction is there, then you change your mind, plot this manner. Okay? The line is done. It may be 1/3, 1/5, whatever, this method will work. So common region, let us trace now. This is G, C, L, D, and F, because they are intersecting, sorry, they are intersecting in this portion only. Let me show you. They are intersecting here only, where all three lines have common region together with x and y axis. This is the region, common region. I am writing which one is the common region. So this portion for common region. Understand? This one for common region. Okay? So common region, better to say feasible region, is what? It is G, C, L, B, F, G. Just to maximize. Maximize or minimize, check once more. This problem was on, oh my god, this was on minimization problem. We haven't taken that, we have taken this one, minimization. This one is a minimization problem. Okay, we have used Isocost method for this. We are going to use. So these are corner points. Isocost, isoprofit method, what we will do? Achha, before that Z is here 4x minus 2y. You find Z at G, 4 into 14 by 3. Z at C, 4 into 14, 56. Z at L. Z at L, you need to write. L means point of intersection of AB and CD. Okay, these two lines, where do they intersect? This point from graph you will always count. Okay, you find this one 10, 4. You need to draw accurately. Better graph also required. I am using rough sketch, no? I got x10. x10 means y is 4. So 10, 4. You need to find Z at L. 40 minus 8. 32. Clear? Z at B. Z at B. B means 0, 14 minus 28. No. Z at F minus 14. No. No. It is maximum at the point C. 56. Okay, but for minimum value, which one do you need to consider? No negative value, please. For minimum, what you are going to consider? Out of these, minimum most value occurring there or here. They are actually region unbounded means it is minimization problem. Here problem is, region is bounded, but they are still asking the minimum most value. So where you get the minimum most value? Then I have to follow the procedure wherever we are getting. What to do? The method is you put the least value of or maximum value of 4x minus 2y equal to 1. Let's see what happens. 4x, we are taking this line, no, this one. Put some arbitrary value over there. 4x minus 2y equal to say 8. I am taking some large value. Or you can take more. 4x minus 2y equal to say 56. So x by 14, y by minus 28 equal to 1. Plot this line and move it parallel towards the origin. So 14 and minus 28. And minus 28 somewhere like this. Okay. So the line you take now, which you are going to move, is the line. Since minimization problem, you have to move it towards the origin. The point at which you get the minimum most value, that has to be considered always. Wherever you get minimum most value, that you need to take. Okay? So let's see what happens there. Which line we are going to move? This one. Okay, take different coloring here. We are going to move this line. this line we are going to move parallel to it. Where it intersects, at last, that will be the minimization thing. So move it, intersecting there. So this point is the minimum most value over there. Please check once. This is the minimum most value. Region is bounded, that's why it is happening this way. Okay, maximum value is supposed to be expected. They asked minimum value. So this is the way. Now, let us solve a practical problem from LPP. We are going to solve a practical problem from LPP. Just a minute. We will be solving this problem. You all can see that on the board. And I like to solve both the way, that by corner point method as well as by isoprofit or isocost method. Okay? Let us plot. To maintain his health, a person must fulfill certain minimum daily requirement for several kinds of nutrients. Assuming that there are only 3 kinds of nutrients, calcium, protein, calorie, and person's diet consists of only 2 food items, 1 and 2. Price and nutrient content given over there. Just go through the table once. Just go through the table once. We have to form the equations. Calcium, food per pound given, food that per pound food 2 also given. This is food 1, food 2, minimum daily requirement given. Protein 5 here and 20 minimum. 2, 6 and 13 minimum. What combination of 2 foods will satisfy the daily requirement and entail the least cost? Formulate this linear programming problem and we will solve it additionally. Okay? So let us plot one by one. Let us frame the equations first. Okay? So what are the equations available here? That we write one by one. This cost of food we are going to minimize. Before that, you assume that food 1, this type 1, X units manufactured and this one Y unit. Okay? So what going to happen there? You have to minimize the cost. Minimize Z is equal to 0.60x 1.00y. Okay? What are the conditions over there? Food 1x, so 10x subject to 10x plus food y, number 1 in equation, 5x number 2, and calories also minimum this much required, so 2x plus 6y, isn't it? So, and xy obviously greater than or equal to 0. You understand? Problem I have formulated as a mathematical problem. So this you are going to minimize under these conditions. What will be the statement I told you earlier? We treat given inequations as equations only. Given inequations as equations only, we will treat that way. So 10x plus 4y 20, that is x by 2, y by 5 1, 5x plus 5y equal to 20, that is x by 4, and this one you divide by 13. There is a problem here because 13 by 2 it will come. And here 13 by 6 equal to 1. So what have I told? For this, you go for plotting the way you used to do in junior classes. First graph is very easy. Let me do it. I'm going to plot. This is x-axis, we take this more prominent. This is your x-axis, and this is the y-axis. Okay? One thing you can do, 6 squares is equal to 1 unit. Then plotting will be very easy by intercept method. But why do you take trouble when you have the method of plotting this manner? I am talking about this line only. But getting even point will be very difficult here. Whatever value I take, that always will be even. So either approximation or assume 6 units equal to 1. But 6 units equal to, 6 square equal to 1 means it will be huge. Okay? But the graph paper you are provided, there you can get the scope. Because only one graph will plot. It may be very big, but it will come there. Here it is not fitting. So I will be going by approximation here. Suppose this one 2, 0. I am just taking approximate data, and this one going to be 5, 0. This one 0, 4, 0, 2 approx, and 0, 13 by 6 approx. 13 by 2 somewhere like this. Same. So first one 2 and 5, or 5 also there, no? Like this. 2, 0 and 0, 5. So plot this. Approximately done. AB. Graph to the technique I told you that will take. 6 small squares equal to 1 unit. It will definitely come. And very nicely it will come. And this point is 0, 5. Then 4, 4. 4 here. Achha, this region greater than or equal to, no? So it will be away from origin. This one I am just taking this away from origin. Solution in LPP always lies in this coordinate. So useless to draw this. Okay, initially you can draw. Now this one 4 0 and this one 0 4. So we will be taking a line through 4 0 and 0 4. Okay, this is CD, C and D. And the last one 13 by 2. 13 by 2 and 13 by 6. Achha, region will be again away from origin. For blue one also away from origin. CD. And then 6.5 there and 13 by 6, 2 point something is there. Yeah. Just a minute. Yeah, almost done. And this region, this is also greater than equal to. So away from origin. Now, can't you see that white line, blue line, this yellow one intersecting at A, B, oh sorry, B is this point. B already taken, so don't take it as B. Point of intersection only you can take. This point of intersection there, this is E, this one is there, F and B. So A, E, F, B on one. To continue. Those points I need to know. These points I need to know. A is automatically there, and A, I told you this is 13 by 2, 0. So A is done, B is known 0, 5. You need to know E and F. When you have plotted that manner, no, it will come nicely. There is no issue in it. You can get it very fast if you have plotted that. If you don't plot, then I cannot help. Okay, then from that, just let me solve it. I am writing because I am not using proper graph paper. So I am getting solution that manner. Okay? Just a minute. What I am going to do there, I am going to solve 2 and 3. You will not solve, and instead you will take the points that manner. I mean, taking x, y like this, the way I was trying to do. So the point E, that point of intersection of AB line is here, and CD, so y going to be equal to 10 by 3. Okay? These two. If I solve it, because my graph is not accurate, right now I have to solve it. So what I am doing there, I am solving those two equations. In exam you never show your calculation. Even if you have done it, never show the calculation. It will be cancelled at that moment. Okay? Graphical method only. 4 minus 10 minus 6y y 10 by 3 2 by 3. So 10 by 3, 2 by 3. When we have solved AB and CD. these two lines. This one is what? This last one and this first one. Last one and first one, they are intersecting here, isn't it? So I need not consider that part. Instead, last one and second one, let us solve that. These two. This I am showing you because just this point E, my calculation is shown here 11 by 4, 5 by 4, and this point is 11 by 4. So corner point method I am not interested to discuss. What you have to do there, give a minimum value to this, then move it parallel, or maximum value, then move parallel. Maximum value means we are letting 0.60x y equal to, say I am taking 0, I told you to take a large value over there. So this has value, say 30. But that if you divide it will be close to origin. So you take smaller value like that. 0.06. So if you divide give 1 only, no? 1, close, no problem. So it will be 0.6 is what? 3 by 5. X by 5 by 3, y by 1 equal to 1. So 5 by 3 is a point somewhere like this, 1 is a point somewhere like this. Okay? You move it parallel to it, where it will intersect. Closest to the origin, it will be the curve. Or, if we have taken right hand side large, suppose the line 0.60x, we have taken a value 0.06, say. Then this line, if you plot, it will be a line like this. Like this. Now this line will be shifting parallel towards the origin. Okay, where it intersects, that will be the minimum most value. So what have you done? You have taken the arbitrary value 0.06. Plotted it, you can take any value, then move it parallel to itself. It's going this way, this way. At the end, it is intersecting at a point which you all can see that coincides with E. Okay, F is not that point. E, it is intersecting at E. E is closest to origin. So, no, not E. Check carefully. It is intersecting both E and F. So it has minimum most value is at E and F. 5 by 4, 11 by 4. Be careful. When you get 2 points per minimization, then you have to add one more statement over there. It has minimum value at E and F as well as at points in between E and F. What the point? It has minimum most value at E and F and in between any point E and F. Now put those values over there to get the minimum most value. Thank you for staying with me. See you again.